Hello, this is Darren Pulsifer, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, Artificial Intelligence and Security. Recently, I had the opportunity of teaching a class for Intel for some up-and-coming students that are in high school and in college. And it's a series that we do over about an 8-week period for these students. And experts come in and talk to them about different aspects of artificial intelligence. And they asked me to come and talk to them about securing the operations of artificial intelligence. It was really fascinating talking to these students and asking them lots of questions. So today we're going to talk about what feedback they gave us as far as artificial intelligence go, and I had them do a bunch of research. It was actually a lot of fun talking to these students. So the first question I asked them, go out and find some failures of AI, some AI algorithms or techniques that were used that failed for lots of different reasons. So they found some interesting ones. 4 of the top ones I thought were really fascinating were the Microsoft Tay, which was a chatbot left out on Twitter, that it did really well, but as people found out it was a bot, they manipulated it by giving it racist comments, and it became very racist and discriminating, primarily because of the data that it was being fed by Twitter feeds. So another one that shows how important data is Amazon's recruiting tool. When they first had the recruiting tool come out, they actually fed it with all the resumes of the people that they had hired and that were successful at their jobs. And they were hoping that this tool would help take the bias out of people reading resumes. Well, of course, it was totally biased because it only looked at the resumes of people that they had hired, which were mostly at that time male. So it was excluding almost all the female candidates in their selection criteria. Another one, this one's hilarious, again, around data. It was Inverness, Caledonian football club, and they put together a ball tracking system that was going to track the ball throughout the field and the players and help determine better strategies for playing the game and things like that. Well, the first time they unleashed it, the ref that was out there was bald. It tracked the ref instead of the ball. I thought that was pretty funny. The kids found for me. Again, another data problem is what it turned out to be. And then there are some AIs that have been very dangerous and have taken some lives, like the case of the Uber self-driving car. When it came out, it killed someone. A very, very sad situation and very serious. Well, it turns out when they did all the training on this autonomous vehicle, it only was trained with data where pedestrians were walking in crosswalks. And so someone was walking outside of a crosswalk, did not see that it was a person, and therefore the fatality that we have. So all of these AI failures that we found, that the team found, all these students, all had to do with data. And AIs are very highly dependent on data. So understanding the data aspects of AI is very important, and securing those is very important. So when you first start looking at deploying AI solutions, there's some things you need to ask yourself. You need to ask, first off, where are you going to be doing your inference? And this is primarily for neural networks, but the same concept can apply. Where am I collecting my data, and where am I doing the AI? Where am I actually doing the inference? Where is that coming from? And that's important to understand, because if it's at an endpoint, if I'm doing all of my inference at the endpoint, maybe it's a camera, I'm doing object detection, I need to make sure that's secure, that no one can manipulate the data or the camera or the model on that endpoint. Now it brings up the other point: is where is it? What is going to actually get deployed? Am I deploying a neural network out to the edge, or an algorithm out to the edge, or am I just streaming the data back from the edge into a data center and doing all the inference there? There's lots of options now with new chips that are coming out, like neuromorphic processors. We can move all that inference right out to an edge device and running on very small wattage and really close to where the data is gathered. Or do I gather all the data and bring it into a data center and do all my processing there and then send results out somewhere else? These are all big questions that you have to be able to answer. And also, when you operationalize AI, you also have to look at how often am I going to update models or algorithms? Do they get updated? How do they get updated? What's the plan there? All right, so these are all big questions that you need to ask yourself. So what I did when I first started investigating this concept of security and operationalizing AI, I went back to my roots. And my roots is configuration manager. Back in the good old days, the Buildmeister, we were the guys that did sysadmin kind of on the side for the team and development. And that was the birth of DevOps. So I fell right into DevOps, right? So I said, okay, let's take a look at how does this fit into DevOps? Well, with AI, it's a little bit different. Not too much, but a little bit different. There's some extra stages, like I have an inference stage or a training stage, right? I also have testing and deployment and development. So when I'm doing development of an AI algorithm, I can be developing the application or starting to develop the model. Then I have a bunch of source data that I add in, and that source data goes into inference, and I build out that source data, and that's a very tight loop. Building out the inference, I'm making changes to tagging data in my source data. I may run it into test and see if it's testing like I want it to, and then run it back into inference, and that can be a really tight loop between there. But if you notice, I talked about three different things: an application, a model, and data. And if you look at the whole pipeline, development, training, testing, deployment, and inference, you're going to find that I need the application, the model, and some kind of data. So there's three things that need to go in that pipeline together. And those three things need to be protected together, and they need to migrate through that pipeline together. So even at the inference, when I'm out in production, that production data, I need to make sure is being manipulated as well. We're going to talk about some of the threats that are out there in this space. Now, first off, let's take a look at some of the AI security threats. There's lots of different reasons why, and we're starting to see all of these reasons, especially during COVID. There seemed to be an uptick in the number of cyber attacks, as we've talked about on the show several times. Some of the reasons for AI threats could be espionage, it could be sabotage, it could just be fraud. Right? There's lots of different things that could go on here. The thing is with AI is there's a bigger attack surface because I'm now collecting data out in the real world. And the AIs are working on that data. So there's a lot more sensors. There's a lot more, the attack surface is much larger. So we have to look at that and be wary of that. We have to protect against that. So let's take a look at all the places I can attack and where I need to worry about. First is the models. If someone can manipulate my model, then where I was supposed to see a stop sign, maybe I don't see that stop sign anymore. Or maybe I'm supposed to detect a cyber attack through pattern matching and things. And if someone's manipulated my model, I'm not going to see those attacks anymore. So I got to protect my model, and I can't just protect it during training. I have to protect it during test and deployment and inference. So we need to encrypt. We need to protect and access control on that model and version control it just the same that we would do with the application. Right? And we need to be able to tie those together. So following really good software development DevOps in the AI space needs to happen. And right now, it's not happening as much as it should because AI is still kind of in that experimental phase. Oh, I need to move fast, so I can't have all the restrictions of a DevOps process. I don't believe that's true. I actually think I can move faster if I have a good DevOps process that takes care of a lot of the things that I should be worried about around security and model integrity and all those things. Now, the other thing I have to protect as well is my source training data in the training stage. I can't have people manipulating that data either. Right? And there's lots of, and we'll show you some of the attacks that we've seen already on these types of data. And that data in my training data needs to be consistent with my test data. All right. So then when I get to production data, I can guarantee that my AI algorithm is working appropriately. But there's also attacks on production data, which I'll show you some examples of as well. So as you can see here, I have three things I need to protect: the app, the model, and my data. My source data, test data, production data, depending on the phase that I'm in at the time. Okay, let's talk about some of the attacks. This comes from a great paper that I looked up on Belfour. Great paper on security and AI attacks that are out there. And what they did was they broke it into two axes. One is a perceivability or a visibility axis, and the other is a format axis. So let's talk about the format axis first. The format axis says whether it's digital or physical, and it could be in between there as well. So a great example of a digital attack would be changing an image after it's been captured. A physical attack would be something that I change the way something looks out in the real world. For example, adding stickers, white and black stickers or different color stickers to a stop sign so that it can no longer be identified as a stop sign. And those are some examples of that. Now on the visibility axis, I have perceivable and imperceivable. So a perceivable one is one that I can see with my eye or hear with my ears or with my sensors as a human being. Well, imperceivable means that the AI algorithm can perceive it, but we cannot. And there's some great examples of that we'll show you here in just a second. It could just be painting something a different color where we see, oh yeah, we see that color, but it's somewhat perceivable to us, but in reality, the AI algorithm perceives it as something different. So very interesting. I'll show you some examples or talk through some of the examples with that. So the first one is a physical attack. So this one they learned really quickly with autonomous driving. And you also see it with object and facial recognition as well by placing certain patterns on the physical object, like a stop sign or a human being. I can get the AI algorithm to not recognize it as a stop sign, even though as humans, we can perceive that as something that's doable. I remember when facial recognition first came out, that they were talking about people were just putting like black and white stickers on their face. That was pretty, it was fooling some of the AI algorithms, but they become much more sophisticated since then. But that's a type of attack. Now, this one's really hard to combat in the physical world. That means we have to do a better job at training our AI algorithms using reinforced learning, and negative case learning is some of the techniques to combat that. Now, there's also a digital invisible attack. And now this one's interesting because perceivably, I cannot see the difference in the digital. And a lot of times what they'll do is they'll just inject white noise into your data stream. So if you're streaming your data from the edge, from a camera or something, and I can put a bunch of white noise in that data stream as it's coming back and being inferenced in the data center, for example, then it can completely throw off the algorithm where something that may look like a panda no longer looks like a panda anymore. Maybe it looks like a monkey or something else. And these white noise patterns are very effective, and they're hard to combat against, unless I'm doing my inference at the edge, or I'm doing some kind of detection of these types of patterns that I'm seeing. But they're hard to detect. Okay, physical attacks. We've talked a little bit about some of them. There's a whole ream of different ones that are out there. Everything from stickers on things, painting things a different way, splash marks on things. There's lots of even smudges on cameras have been used as physical attacks to really change what object is being detected. And then on the digital attack side, we're seeing both it happen in the data stream itself and also in the test images too. If someone can hack in and do imperceivable attacks on your digital images, you're not going to be able to identify those images easily. So it's important that you know where your source data is coming from for the training and also your testing. It's a lot harder in production data because there's lots of things that can go wrong there. So, but securing your endpoints is key to protecting against these types of attacks. Okay, one thing you absolutely need to work on is identifying your data sources, both in that source training data, your test data, and production data. So you need to identify where is the data coming from, especially in your test data. There are a lot of public data sources that are out there today that a lot of people rely on. Make sure that you do have a verified and attested data source that you're getting that from, public data source. Remember, if it's open source and not guarded very well, there's always a chance that someone can inject bad data into those, and which could completely make your AI algorithm not useful, right? Also, consider looking at generating data sources and things like that, so that you have more control. So even if you're using a public data source, my suggestion would be to use a version control system like GitHub or GitLab or any of the version control systems that are out there. Check in your data, make sure it's consistent. Any updates to it should be version controlled as well. Now, to me, that's the same thing with your test data. If your training data and your test data are identical, well, it's always going to pass. So you need some changes in your test data over your training data, but you need to make sure that your test data is also under version control and access controlled and all the things that you would normally do for a DevOps pipeline. Now, the last one, and probably the hardest, is the production data. And how do you protect that production data? This one's really hard because you're gathering this production data, the data that you're inferencing. You're grabbing this from sensors that are sitting out in a factory or in a city, or maybe it's just log files that are coming in from your network switch, so you can do cyber threat detection using AI algorithms. The key is to protect it and to make sure that that stream is not being manipulated before you're doing your inference. Some of the tricks on this is to do your inference as close to the data as possible. And like I said before, with some of the new technologies with neuromorphic processing and even some of the instruction sets in the Intel processors, I could do a lot of this inference right there on the edge and not worry as much about the data being manipulated over transport. Instead, I can encrypt the data, the object data that I'm gathering from those data streams, and send those back to the data center. I can do the same also with the data streams themselves. It's a lot more data. So it may take there may be some latency issues that you have to deal with. Right? Unless you use something like an FPGA, which I've seen some of my customers starting to use FPGAs to do the encryption and the transport normalization of data streams into inference engines. Very interesting stuff. Okay. Once you've identified all your data sources, you need to understand how to protect and manage that data. Now, there's three key aspects. First one is control, right? This is version control, protecting the data, the libraries, the algorithms, making sure I have backup and restoration in case I get data files that are corrupted, that I can go back to where I need to go. These are just common good security practices that we need to follow in our AI practice as we already follow in our app development practice, right? Security, basic, simple, AAA security here, access, authorization, authentication. You can even use some zero trust concepts here as well on giving temporal access to people that need it for only a short period of time. Specifically, take a look at those models. Make sure those models are not being manipulated. Also, make sure that your models are tied to specific applications. We've seen this case before where a model was built out and then overlaid on another neural network accidentally, and it failed completely, obviously, right? Because the model was not matching the neural network exact. So there's issues you got to deal with there, and that's a sort of attack as well. The other thing I would suggest is make sure that you're encrypting your data. Encrypt it at rest. Encrypt those models. Encrypt your data streams coming from your endpoints. And also, for highly secure or high confidential AI that you're doing, consider using data in use encryption, like Intel's SGX secure enclaves, for example, or TDX total memory encryption technologies that are out there. Encryption in the past has been touted as being very expensive as far as CPU utilization and time. That is not the case anymore. A lot of the encryption is in silicon and very fast with minimal to no performance hit nowadays. So with these three techniques out there, you need to go back and look and see, all right, in my secure AI pipeline, where do I need to place controls? Where do I need to place security? And where do I need to place encryption? Don't forget about encrypting your models, right? This is a really important thing to do, right? You don't want someone manipulating your model as it's being transported maybe out to the edge to do edge inference. So you need to protect that as well. So just remember, it needs to be protected in each stage of your AI deployment, both in the training, testing, deployment, and inference stages. Even in development, when you first have things kicked off, and you're first developing that model for the first time in your AI application, make sure that you're versioning control, only giving access to those that need it instead of just opening it up to the world. So to close out, here's your call to action. Go out and protect your data. Your data is going to be key to making your AI successful and secure, right? In fact, there's a lot of regulatory organizations, government is starting to figure out how can we make AI more secure and more viable for the future without fear of these types of hacks that we've seen, or without fear of an AI not being validated appropriately. So go out and protect your data. Start using those best practices right away around security. Operationalize your pipelines so that you take the human out of the day-to-day grind of deploying and testing your AI algorithms. Automate as much as you possibly can, and make sure that you're injecting security into that pipeline in your DevOps pipeline, or what is going to be called. It's going to be AI DevOps, or they'll come up with something funny. Intelligent DevOps, artificial intelligence DevOps, I don't know. But use a DevOps pipeline. Remember to protect your source data, your model, and your application window. Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, Give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about embracing digital transformation at embracingdigital.org. Until next time, go out and do something wonderful.